Hello, good morning. Let's introduce our new topic of Unit 1 under data analytics. That is need of data analytics. What is a big data life cycle look like? How it is, how is data actually processed when dealing with a big data system? Right? Approach to the implementation different. There are some commonalities in the studies and software that we can talk about generally. All this represented below may not be true in all cases. They are widely used. General categories of activities involved in big data processing. The ingestion of data into system, processing the data in storage, computing and analyzing the data, visualizing the results. Okay. So this is a general life cycle of the data, system data in the system for the data processing. Data, how the data system is defined in that data system, how the injection is done, how the persistence, the data storage is done, how the computing analyzing the data is going to be done, how the visualizing the results have been done. Okay. So this is collect, store, analyze, and governance. Collect, store, analyze, and governance. That's how the data is going to be valid on the data. If we look at the these these four workflow categories in details, we will take a moment to look about the clustering, computing, and more strategy provided by the big data solution. Setting a computing structure cluster is often foundation for the technology used in any lifestyle stage in the big data computation. In general, we try to collect data, then we store the data, then we analyze the data, then we have a governance, and we get a value from the data. Okay. Now, cluster computing. Because the qualities of the big data, individual computers are often inadequate for handling the data at the most stages. Better handles the high storage and computational needs. Big data computer clusters are a better fit. Big data computer clusters are a better fit. Big data cluster software combine the resources of the small machine, seeking to provide a number of benefits. Okay. Now, resource pooling. Combining the available storage space to the whole data is clear benefit. Okay, but CPU memory pooling is also extremely important because it we need to process those data. Large data set requires large amount of power resources. That is, uh, we need to be space and memory pooling and large data sets need all actually. Okay. So, in the cluster computing, individual computers are often inadequate for handling the vast setup. So we try to connect to many nodes, to get a better high storage compute and satisfy the computational needs of a big data, and the computer clusters are better better fit. Now, so what are the qualities of the cluster computing will be? It will have a high storage, then it has its own computational needs and and there should be see the CPU and memory pooling. The mechanism is also very high to manage the large set of the data. So when we initialize the big data lifecycle, initial data into the system, persisting the data in the store, computing, analyzing data, visualizing the results, we used to have the following thing: connect, store, analyze, and governance when from the data. Okay. Then comes the second property, the cluster computing has a high availability. Clusters can provide varying levels of fault tolerance and availability. Guarantees to build hardware or software failure for affecting access to data and processing. Okay. It's becoming increasingly important as we continue to emphasize the importance of the real-time analytics. Okay. So clusters can be provided varying levels of the fault tolerance and guarantees to implement hardware and software failures for affecting access to data and processing. It's become increasingly important as we continue to emphasize the importance of the real analytics. Okay. Now, third property of the clustering is the scalability. Scalability is how much you can expand a data set connection. So here we can expand it horizontally by adding more machines in the group. Okay. By adding more machines in the group, we can expand horizontally. And this means that the system can react to the change in resource requirement without expanding the physical resources on the time. Okay. How this cluster will be implemented in the cluster membership, coordinating resource sharing, and scheduling actual work on the individual nodes. We see the cluster members in on resource allocation can be handled by software like Hadoop YARN, which stands for at another resource negotiator. Okay. And the Hadoop YARN we need to follow three properties, that is the resource pooling, high availability, and easy scalability. Please taken can make this resource manager. Client need to access. Just resource manager just makes each and every node where the container and app master agents has been there to monitor the thing. So in this, these are the individual nodes where the data nodes are there. And the data nodes are pooled, and with the help of the node manager, we are able to get resource pooling and resource manager also, which creates a node manager as the individual nodes. Then from the creation of the individual node, we will also get a high availability. Okay, then and from this, with the effect of the resource manager, we can add as much as node as you want. That is what easy scalability is all about. Hadoop is a big software Apache Hadoop software which help us to create a big data environment. And that Hadoop is overall an environment actually. We came in to know about this later, in which a Hadoop YARN, which stands for the another resource negotiator, Apache Newport, So this assembly computing cluster often acts as the foundation which other software interfaces to process the data. The machine involved in the computing clusters are typically involved with the management of the distributed storage system, which we talk about when we discuss about the data persistence. What really the data persistence is all about? Once the data is free, it should, when it is updated, when we update some data, it should be updated across the position where it has been stored. Working in the cloud computing nowadays, we get a resource pooling by the cloud computing as well. Now, let's move. What are all those 4 steps actually which we use for the data processing, data ingestion, ingesting data into the system, persisting the data in the storage, computing, analyzing the data, and visualizing the results. Now, data injection is the process of taking raw data and adding it to the system. Setting of the operation depends heavily on the format, because the format issue is always with the data. Format issue this format issue So, data ingestion is the process of taking raw data and adding it to the system. The complexity of this operation depends heavily on the format and the quality of the data sources, and how far the data is from the desired state of prior to be processed. Now, processing. Now, see, one way that the data can be added to a big data system are dedicated ingestion tools. Okay. Technology like Hadoop is good. Again, we will understand the whole ecosystem of the Apache, but in future, as per the discussion, we are introducing those technologies which are used for the purposes like whatever it is defined. Now here, the when we consider the big data system of dedicated ingestion tools, then we use the technology like Apache Scoop in it. And how it is going to use, see in the figure that we have a RDBMS, MySQL, wrapper, PostgreSQL, DB2, and we use this scoop tool. Then we import and export the data. And finally, the Hadoop system works out. Okay, take exciting data from the what is happening actually. We take the data from the relational database, add it to the big data system. Similarly, Apache Fumes and Apache Chukwua's project designed applications and server logs. Okay. Wing systems like Apache Kafka can also be used as the interface between various data generators and big data systems. Now, we have introduced Yarn in the cluster management, and we introduce the system. In the ingestion data, we introduce the Apache Scoop, which take existing data from the relational database and introduce a big data system. And then we take Apache Fume and the Apache Chukwua, which is used to aggregate and import application from the server logs. So when we want to take a data from the relational database, we will use the Apache Scoop. But when we want to take a data from the server logs, then we will use Apache Fume and Apache Chukwua. And queuing. Then after that, we will use a queuing system. Queuing system, when we try to line the different processes in the queue. Then here the Apache Kafka help us, which is used as an interface within the various data generators and the big data system. And we have for ingestion, we have our framework like Goblin, which helps us to aggregate and normalize the output of the tools at the end of the ingestion pipeline. Okay. Now here the producer A, producer B, producer C, like this. So Apache Kafka, it is doing its work, as per discussion. Apache Kafka is just becoming an interface and from the various data generators and which is pushing the data into the big data system. Big data system, which is managed by the Apache BP, in which there are the many agents, which is which is clustered according to the customer group, and that customer group is directly going to be stored in the storages, which is managed by the create streams and links and data spark. Data spark, what I'm saying, it is like it's managed by the Spark software, actually, it's not data spark. So this in the process of the indigestion, we came across this finally we are extracting information from somewhere. Then we transform information from one interface to another interface, and we load the information to the final SDFS server as ways, what to say, big data configuration. So every indigestion process, we have some level of analysis. Then we sort that data, then we label that data. And this process is something sometimes called ETL, which stands for extract, transform, or load. That's what the ETL is all about. That's one. So how does this ETL work actually? ETL works, first of all, we extract the data, extraction. Then we, it's only important data. Then we stage the staging area. Then we transfer and load only the important data. And here the data mining and warehousing has been done. And, then we have extraction. Then we have we got a staging area and transform and loop. Then presumably important data has been done for data mining and warehousing, which is transferred to data mining and warehousing. And from there, after the process, from the processing, we get the analytics. This is the term of on the whole process of ETLs are. While this term conventionally refers to the legacy data warehouse processes, some of the same concepts apply to the data entered the big data system. Typically, operation might include modifying the incoming data, formatted, categorizing, and labeling the data. filtering out the needed or bad data or potentially validating that is adheres with a certain requirements. In those capabilities, right, ideally, the captured data should be kept as raw as possible for the greater flexibility further down the pipeline. So this is an introduction of the ingestion of the system. In the second step, we try to get a persistence in the data storage. So the ingestion process typically has data of component in the managed storage so that it can be reliable, persistent to the disk. Persistence, it is available to the disk, and whatever update will be done, it is done. It should be done to the disk end. If it is not till the disk end, it will get rolled back to the original position. While this seems like it would be a simple operation, the volume of incoming data and the requirement for the availability and the distributed computing layers make more complex storage system necessary. Large data sets. For this, we have a SDFS file system. This means leveraging a distributed file system for raw data storage. Solutions like the Apache Hadoop SDFS file system allows large quantities of data to be written across multiple nodes in the cluster. This ensures that the data can be accessed by the computer source, can be loaded into the cluster's RAM for in-memory operation, and can gracefully handle component failures. So how this SDFS of Hadoop is working? We are just getting a compute source and which is loaded on the cluster, and the RAM available which is loaded on the cluster, and cluster is using the RAM for the memory operation, which is here, and it is designed to gracefully handle the component failure as well, because it is a distributed system where the other distributed file system can be used to place SDFS, including 7 cluster FS. Okay. Now this is the Hadoop ecosystem. So Hadoop is like a big elephant, and it's different system and different technologies are having introduction, like Big Scoop, Jupyter Flew. We have introduced the NAV2 technology, HWave, Shark, Spark, Storm, Cascading, Solar, Scoop. It's a expert. We had this is the ecosystem in which we introduce technology as per the need. What we are talking about. But now we came across that data need to be imported from the distributed system, from various location to the distributed system, which is data analytics. So how it is going to work? So first of all, data can be imported to the distributed system for more structured access. Okay. Distributed databases, especially NoSQL databases, are well suited for this work because they're often designed with the same fault tolerance. Consideration can handle heterogeneous data. There are many different types of distributed database to choose from depending on how you can want to recognize and present your data. If you want to really understand this, learn about the NoSQL. I'm just going to delete this to avoid the confusion. Where I make introduction that NoSQL database is well suited for this distributed database application. And what is happening in distributed database application? Data aggregation of several forms, which is creating a network log, server logs, storage logs, web stream. We just collect with the help of the Apache, so we just collect that data and put it in the data analytics environment where we have Hadoop cluster, which is name node, which is going to be with the help of the PIC, Apache PIC. We use a scripting for the job scheduling to the different data nodes, which in which we are handling the SDFS, this SDFS introduction we have done here. And what is SDFS is all about, and SDFS is the file system, and then file system is indexed, and which is with the help of the Apache Solr, we have a region server and region server, which is help us to bring the reporting, which is help us to bring the reporting from data access and web services from, which help us to bring the reporting. Now, we also get the data from the BI clients and the customer as well. So this actually help us to get a data analytics part. So this is the way we try to get analytics into to get a more insight patterns and the patterns and from which are that's decision taken care with the help of those available softwares. Okay, and then making this and action so coordinated that it looks like nothing is nothing to worry. We are only usually the managers are more focused on the that reports and presentation. Many things are many things and many softwares are working to present those presentation and analytics modeling is working behind the picture. Okay, we'll learn it later in our subject. Then we come at the point of the computing, analyzing the data. Once the data is available, the system can begin processing the data to surface actual information. Okay. The computational layer is perhaps the most diverse parts of the system, as the requirements and best approach can be very significant depending on what takes inside design. Data is often processed repeatedly, either iteratively by a single tool or by using a number of tools to surface different types of insights. Okay. Let's move ahead and understand simple formulas of Apache. We have our system. We have a structured or semi-structured data or structured data. For semi-structured or unstructured data, we have a flu, and we have for structured data we have a scoop. We just import or export the thing to the this SDFS or the distributed file system. Then we encoded eco network in which we are creating a distributed file system database with technology like NoSQL. Then we use a MapReduce framework for the HBase and for HBase in the sense which is this one helps to define a server for the processing that all data. And then we have a different systems like Hive for the data warehouse. Then we have a Pigland and data all the data analysis. Then we have a Mahat for the machine learning, and then we understand this Apache Cozy work. This is what Apache Cozy work is all about. In fact, we came across that while creating a big data system, we're also creating a platform where our data analysis will be done with the help of the machine learning. And with the help of the machine learning, we will get a patterns and those hidden aspect of the information what we want from that what we want from that data, actually that raw data, which we transform it from the raw data to that homogeneous clusters. And then that homogeneous clusters we go to the process create information, then information has been further categorized for the that is information to knowledge. Okay, this is all the step we take care of in the process. Now we understand a little bit about this Apache ecosystem. We understand the batch process. The batch processing method or computing over large data set. The process involves breaking work into the smaller pieces. Pieces in so during each piece, one machine. Okay. They shuffling the data based on the intermediate results. Then we calculate the assembly final results. First of all, what we are doing, we are just think like we just put take a large data set and we try to break it out in small pieces. We schedule each piece, the individual machine, and we shuffle that data based on the intermediate results, and then calculate and we have that computers and the 10 data set that each computer has to process one data set and finally getting a computation. Validating computation. Getting a computation is done, getting computation is then collected and then it is assembled. So these systems are often referred to individually as the splitting, then mapping the data, and shuffling, then reducing and assembling, collectively as a distributed map reducer. This is a famous map reducer algorithm, which is backbone of the Hadoop technology. This is still used by the Apache Hadoop MapReduce. Batch processing is the most useful when dealing with very large data sets that require quite a bit of computation. This computation part is not dependent upon the single system, nor it is an divided into the various system available, and with their computing efficiency, we can handle our data set well. So while we have a batch processing option, but we still move ahead with new technologies as well. But when we're going to introduce the further lecture. Well, batch processing is good fit for certain type of data and computation. Other workloads require more real-time processing. Real-time processing demands that information be processed and made real immediately and require the system to react as new information becomes available. One way to achieve this is stream product processing, which operates on the continuous stream of the data composed on the individual items. Other common characteristics of the real-time processor is in memory computing, which works with the representation of the data in the cluster memory to avoid having to the write back to the disk. Okay. Now we have technology like batch processing, but sometimes we need a processing in the real time. For this, in the ecosystem, we have a different technology. Let me introduce this. And batch processing is good fit for a certain type of data and computation. Other tools requires more real-time processing. Real-time processing demands that information be processed immediately and immediately. Requires the system to react as new information becomes available. So one way to achieve this is stream processing, which operates on the continuous stream of data composed of the individual items. Another common characteristic of the real-time processor is in the memory computing, which with the representation of the data in the cluster memory to avoid having to the write back to cluster memory to avoid having to write back to the, like, like this. And Apache Storm. So for this, we have another class. Apache Storm, Apache Flink, Apache Spark provide different ways of achieving real-time or near real-time processing. There are trade-offs with each of these technologies, which can affect which approach is best for individual problem. Even which we are going to now understand our requirement and then this technology that you going to use to know that much of the cost inputs also involves in this type of technology. So in general, real-time processing is best suited for analyzing these small chunks of the data that are changing or being added to the system rapidly, just to small chunk of data. So that is what a computational framework is all about. There are many other ways to compute analyzing the data within a big data system. These tools frequently plug into the approach. So framework and provide additional interface for interacting with underlying layers. For instance, Apache Hive provides data warehouse interface for the Hadoop, and Apache Pig provides high-level querying interface, while SQL-like attractions with data can achieve with the projects like Apache Drill, Apache Impala, Apache Spark, SQL, and Presto. This Apache ecosystem also helps us in the machine learning projects as well also. Now, machine projects like Apache System ML, Apache Mahat, and Apache Spark, ML library can be useful for straight analytical programming. If we don't going to use Apache ecosystem for the straight analytical program, we have wide store support in the big data ecosystem. And we have two popular changes like R and the Python. That's why you are getting so much emphasis on learning Python in the your academics and the curriculum. Now, the next step to get the thing done in the big data environment is visualizing the result. How does the visualizing of result is taken care? So, during the type of the information being processed in the big data system, recognizing needs or change in the data over time is often more important than the values themselves. So, visualizing data is one of the most useful ways to spot trends and make sense of a large number of data points. Real-time processing is frequently used to visualize the application and server metrics. The data changes frequently, and large data in the metric typically indicates significant impact on the health of the system or organization. So in these cases, projects like Prometheus can be useful for processing data stream as a time series database and visualizing that information. Okay. So how it's processed, the result part, it's like we just get a log, then we collect and transform. Log stats will be Elasticsearch, and then we visualize and manage schema. This is one of the examples of the software environment. The most popular way of visualizing data is with the Elasticstack. This is software actually, formerly known as the ELK stack. Composed of log stack for data collection, Elasticsearch for indexing data, and Kibana for visualization. And this is the software used for this process. Collect and transform, we are using log stack. Search analyze, we are using Elasticsearch, and for visualize and manage, we are using Kibana. So, for can show the big data system visualize interface with the result of calculation of the raw materials. A single stack can be achieved using the project source or indexing in Kibana, and a Kibana for called Banana for visualization. The stack created by these is called SIM. Another visualization technology typically used to interactive data science. In one case, data node. Okay. These projects allow for the interactive exploration and visualization of the data in the form conducive to the sharing, presentation, and the experience. For example, of this type of visualization interfaces are Jupyter Notebook and Apache Jupyter. So that's what we understand why we go through the different technologies in the data analytics process. The popular terminologies are more came across, and we got the reason why to study R or Python. Then we also need to understand why the Jupyter Notebook use Apache software ecosystem in its big data analytics. So I hope this part, introduction of the big data and the need of the data analytics has been addressed to you. It is just an introduction we will explore as per. Hope you understand. So conclusion we will interact. Okay.